Hey, it's African Math Industry, and we are going to take a look at standing waves. So in the past, we have been learning a lot about transverse waves, mechanical waves, the construction interference, the destruction interference, but we're going to take a look at standing waves. But hang on, what is a standing wave? Well, standing waves happen when there are waves that are fixed in between 2 points that are solids, and also they vibrate to have a max altitude. So, if you ever come across something that looks like this, the string or whatever it is, or a cable, is going back and forth really fast to the point where the human eye can't even see the waves. We can use an example of a guitar. Or another string instrument. Notice how when I tap on the animation for the guitar and the other instruments, notice how they create this shape? That's because they're standing waves, because the string is between 2 points that are pulling a lot of tension on the guitar, which is causing it to vibrate really, really fast. But what we're going to try and do is understand the science behind a standing wave. So what we're going to understand now is there are actually different types of standing waves. Sometimes you can have just one gigantic ellipse. Sometimes you can have even more. So what we're going to understand is where is the max altitude happening in these kind of waves? Where is it being neutralized? And what's happening? So, there are two things that we're going to take a look at. Standing waves are going to have nodes and antinodes. Nodes are the place where the displacement is zero or is neutralized because it goes back and forth like crazy, the string. And antinodes are points in the displacement where it's at its maximum amplitude. It's very, very high. For example, right here, top and bottom, is going to be the maximum amplitude. That's an antinode. But if you take a look at the sides here and there, they're totally flat. And these are the points where it's being stretched. These are nodes. We also are going to take a look at these two formulas right here. These formulas only work with standing waves, not with other kind of waves. To find the wavelength, we have the wavelength equals 2 times the length divided by the number of antinodes. And the frequency equals nodes, the antinodes times velocity divided by 2 multiplied the length. That's the frequency. So let's get started on looking at the different types of standing waves. So right over here, we have something called the first harmonic, or called the fundamental wave. That's another way of saying it. So there is one antinode. So we're going to say n equals 1. There are 2 nodes, but in order to understand with the formulas here and here, we're going to use the antinodes. So here's what's going to happen. If you were to simplify, because many physicians and mathematicians try to make math as easy as possible, to find the wavelength, all you'd have to do is write the wavelength is going to equal 2 multiplied by the length. And for the frequency, you would have to do f equals the velocity divided by 2 times the length. So that is what the formula would look like if you were to simplify it from here to here. It's not a good idea to memorize the formulas because that could cause some confusion. But if you know to find the antinodes and to insert them into these formulas, then you will eventually get to these by your steps when solving. But it's easier to kind of just count the antinodes, put them in here, and solve the problem. So let's see what happens when we try to understand what the next harmonic wave is. So right over here, we have the second harmonic or first overtone standing wave. We have 1, 2 antinodes. So we're going to say m equals 2. We are going to have 1, 2, 3 nodes. If you were to write this in a formula, then you would have the wavelength equals the length, which that's really, really easy, and a math question answering itself. We also have the frequency equals the velocity divided that by L. So that is the second harmonic or first overtone wave. Let's see what happens with the next one. We're going to show you the first 5 because those are the most common types of standing waves that you might see. So this is the third harmonic and second overtone. We have 1, 2, 3. This is going to have 3 antinodes, the places where there's a maximum amplitude. And we are going to have 1, 2, 3, 4 nodes, the neutral zone. If you were to put this into a formula, you would have the wavelength equals 2 times L, or length, divide that by 3, because the number of antinodes. And if you were to calculate the frequency, that would equal 3V divided by 2L. So that is going to be for this one. Let's take a look at the next one. So the fourth one, the fourth harmonic or third overtone is going to be a lot bigger. Notice how every time we go to another harmonic and another overtone, we have more of these tiny waves. They get more, but they get smaller each. Just an observation. So how much is this one? So the fourth harmonic or third overtone has 1, 2, 3, 4 antinodes. So we're going to put that as n equals 4. If you were to try to use a formula for this to solve these ones right over here, then we are going to write the wavelength equals the length divided that by 2. And we are also going to use the frequency equals 2 times the velocity divided that by the length. So that is for the fourth harmonic or third overtone. The last one is going to be the most waves, but also the most amount of nodes. So this one is going to be the fifth harmonic or fourth overtone. So here's what happens. 1, 2, 3, 4, 5. There are 5 antinodes. That is going to be a lot. And we also have 1, 2, 3, 4, 5, 6 nodes. That one should actually be colored in. So we have 6 nodes. If you were to ever put this on a formula for here, then we are going to get the wavelength equals 2 times the length, divide that by 5, because the number of nodes. And that's going to be the frequency equals 5V divided by 2L. So yeah, we have understood all the different harmonics and also all the different overtones and how much antinodes and nodes that they have. So, before we end the video, we're going to put this as a reference to understanding the different formulas if you want to understand and look into the different harmonics. 1, 2, 3, 4, and 5. Take a screenshot and also pause the video so you can keep this as notes. So yeah, we now understood the different harmonics and overtone waves and understood a standing wave. Thank you. I hope this video has helped you understand standing waves. Thank you for watching Tao Ping Line's Math Industry. Like and subscribe.